So as it turns out, we can use higher order derivatives to examine the economic growth for a developing country. And problem 32 on page 213 does just that. Excuse me. So as you can see, this thing states that a developing country's gross domestic product, GDP, from 2000 to 2008 is approximated by the function g of t equals negative 0.2 t cubed plus 2.4 t squared plus 60. And again, t is going from 0 to 8, the last digit of its date, of its year. G is measured in billions of dollars, and t equals 0 corresponds to the year 2000. Our job is to compute the rate of change, G prime, for each year. And then also to compute the second derivative for each year, 0 through 8. And we're going to use those results to show that after a spectacular growth rate in the early years, the growth of the GDP has cooled off. So let's start by computing the derivative, and we'll plug in the values 0 through 8 and see what's going on with that. G prime of t is negative 0.6 t squared plus 4.8 t plus 0 for the 60. Let's go ahead and do these values. So I have already computed g prime of 0. When you plug in t equals 0, you get 0 for that thing. When you plug in a 1, you get negative 0.6 plus 4.8. That works out to be 4.2. G prime at 2 works out to be 7.2. G prime of 3 is 9. G prime of 4 is 9.6. G prime of 5 is back to 9. G prime of 6 is back to 7.2. G prime of 7, you can probably guess where this one's going to be. Yes, it's 4.2. And G prime of 8, we're back to 0. Now, remember, this is the rate of change of the gross domestic product. So it starts out in the first year with no change. And then you can see the change is increasing to a point where we're at $9.6 billion per year in 2004. And then it slowly tapers back off until in 2008 our rate of change is 0 again. Now let's go through the same calculations with the second derivative. First we'll need to compute the second derivative. And I think you can see that this is going to be negative 1.2 t plus 4.8. And so we can plug in each year and find out what the second derivative was. So when I plug in a 0, it turns out that this is a value of 4.8. That's $1 billion per year squared. G double prime of 1 is 3.6. G double prime of 2 is 2.4. G double prime of 3 is 1.2. G double prime of 4 is 0. Now it's interesting that that 0 corresponds to 2004, which we noticed was our year with our biggest growth. Let's see what G double prime of 5 is. Plug in a 5 and that turns out to be negative 1.2. G double prime of 6 turns out to be negative 2.4. G double prime of 7 is negative 3.6, and G double prime of 8 is negative 4.8. So there's also some symmetry to this list, except that once we cross 2004, all the values are negative as we come back sort of down the ladder. And you can verify each of these values. I've just plugged in one at a time, 0 in for t, 1 in for t, and when I say that I mean I'm putting it right here where t is. You calculate the value and then list that. And so the second derivative shows us the rate of change of the first derivative. And you can see that this second derivative has a value of 0 when our rate of change for our gross domestic product is at its highest, and then from there it continues to decrease. These negative values for G double prime indicate that our growth is slowing down until we get to a point where it's back where it started. And so in the discussion of these values for the first derivative and the second derivative, we've basically answered what was asked of us in letter C of the original question. So hopefully that helped clear up how to use these derivatives, how to plug in values, and then how to interpret what's happening as you see them. Good luck.